Aromaticity. What is aromaticity? It is the property of ring compounds or cyclic compounds. You know what is cyclic compounds? If the carbon atoms are linked together to form a cyclic structure, it is called cyclic compound or ring compound. So, this aromaticity is a property of ring compounds or cyclic compounds, and it is a function of electronic structure. It is a function of electronic structure. For a compound to be an aromatic compound, or if a compound exhibit as aromatic property, aromatic compound, it should obey certain rules. What are the rules? There are 3 rules which governs the aromaticity. Now, let us see the rules. The first one, the compound should be cyclic and coplanar. What do you mean by coplanar? If the molecule is coplanar, it is aromatic. What is coplanar? All the atoms of the molecule should lie in the same plane. If all the atoms are located in the same plane, it is called coplanar molecule. So, a compound should be coplanar to have aromatic character. Then the next property is, or next rule is, the pi electrons should be completely delocalized. Pi electrons should be completely delocalized. What is pi electrons and what is delocalized? We have to understand the meaning for these 2 terms. For example, the structure of benzene can be written like this. You know, benzene has 6 carbon atoms, and in its structure it contains alternate single and double bond like this. Now, this doubly bonded electrons, the electrons which are involved in this bond, double bond, this bond, these 3 bonds is called pi electron. So, this bond contains 2 pi electrons, it contains 2 pi electrons, and this bond contains 2 pi electrons, similarly this bond also. So, totally benzene contains 6 pi electrons which are all delocalized. What do you mean by delocalized? The bond between these 2 carbon, if is localized, it is called localized bond, or if the bond is not common to these 2 carbon alone, it can be shifted in this direction. This pi bond can be shifted to the nearby carbon like this, and this bond can be shifted to this side, and this can be shifted between these 2 carbon atoms. So, this is called delocalized. Localized means fixed between 2 carbon atoms. Delocalized means it is not located, it is delocated, that is delocalized. So, if the bond is shifted in this way, it is called delocalized pi electrons. Now, after delocalization, you can write the structure of benzene like this. See, these pi electrons are delocalized between these 2 carbon atoms, and these 2 pi electrons are shifted here and these 2 here. So, this structure also represents the structure of benzene, or you can write the structure of benzene as like this. This indicates the delocalization of pi electrons. So, the second condition is the pi electrons should not be localized, they should be completely delocalized in the ring. Then the last rule, but not the least one, is Huckel's rule. What is it called? Huckel's rule. The total number of pi electrons in the ring should be in the form of 4n plus 2. This is called 4n plus 2 rule or Huckel's rule. The total number of pi electrons in a ring molecule or cyclic compound should be in the form of 4n plus 2. Here, what is n? it is any integer like 1, 0, 1, 2, 3, etc. So, n is any integer. Now, the total number of pi electrons should be in the form of 4n plus 2 means what? Apply 0 for this n, you will get 4 into 0, that is 0 plus 2, that is equal to 2 pi electrons. If n is equal to 1, 4 into 1 plus 2, that is equal to 6. If n is equal to 2, now 4 into 2, 8 plus 2, that is 10. If n is 3, then you will get 14. 4 into 3, 12 plus 2, 14. So, if a cyclic compound contains this number of pi electrons, then it is said to be aromatic. So, what is the need to understand about this aromaticity? Actually, if a compound is aromatic, its stability will be more. If it is anti-aromatic or non-aromatic, its stability is very less. So, the aromatic compounds, or if the compound possesses the character of aromaticity, it possesses more stability. Now, let us discuss this aromaticity with some examples. Take benzene. I told you this is the structure of benzene. Naphthalene, it contains 2 rings like this. Then anthracene, which contains 3 rings like benzene like this. This is anthracene. Then cyclooctatetraene. Cyclooctatetraene. What is octa? It is 8. So, it contains 8 carbon atoms. So, it is octa. Tetraene. Ene means double bond. 1, 2, 3, 4. It is cyclic compound. So, it is cyclooctatetraene. Then cyclopropene. Cyclopropene. I will take another example as cyclopropenyl cation. The same cyclopropene with positive charge. It is called cyclopropenyl cation. Then cyclopropenyl anion. Cyclopropenyl anion. Anion means ion with negative charge. So, it is cyclopropenyl anion. Then let us take some other examples. Cyclopentadiene. The cyclopentadiene, 2 double bonds. Cyclopentadiene. Cyclopentadienyl cation. Cyclopentadienyl anion. Now, let us see one by one whether it is aromatic or non-aromatic. Actually, I told you, if a compound or if a molecule satisfies these 3 rules, it will be aromatic. Now, what is the first rule? It should be coplanar. The molecule should be coplanar. This benzene is a planar molecule. It contains all the atoms in the same plane. How to identify whether it is coplanar or whether it is planar or non-planar? If a carbon involves sp2 hybridization, it is said to be planar. So, if you calculate the hybridization for all these compounds, this also is planar. This molecule is anthracene, also planar. Cyclooctatetraene is non-planar molecule. Why it is non-planar molecule? How to identify this? Actually, in your higher studies, you will learn more about this. Actually, this molecule contains 8 pi electrons, which is not in the form of 4n plus 2. So, it is in the form of 4n. If the pi electron number is in the form of 4n, it leads to anti-aromaticity, which destabilizes the molecule. So, to avoid this destabilization, this molecule is non-planar. Actually, it is non-planar. Then the cyclopropene, its cation, anion. Cyclopentadiene, its cation, anion, all are planar. So, the first rule is obeyed by all these molecules except cyclooctatetraene. Now, so cyclooctatetraene is non-planar means what? It is not aromatic. Is it not? It is not an aromatic compound. So, you can rule out this. It is not an aromatic compound. Now, coming to all these things, the first rule is obeyed by all these molecules. Now, come to the second rule. Pi electron should be completely delocalized. We already studied about this benzene here. It has 3 pi bonds, that is 6 pi electrons, which are completely delocalized. This can be delocalized here, this can be here, and this can be here. So, it contains 6 pi electrons which are completely delocalized. So, second rule is satisfied by this benzene. What about this? How many pi electrons? 2, 4, 6, 10, 8, 10. So, 10 pi electrons which are all completely delocalized. Is it not? It contains alternate single and double bond. So, you can say it is completely delocalized. Its pi electrons are completely delocalized. Come to this anthracene. Here also you can find alternate single and double bond, isn't it? So, this is also containing how many electrons? 14 pi electrons which are completely delocalized. What about this? It contains 2 pi electrons. Can it be delocalized? No, it cannot be delocalized. Why it cannot be delocalized? See, is there any alternate single and double bond? No, here continuously 2 single bonds are here. So, it is not delocalized system. These pi electrons are not delocalized. Then what about this cyclopropenyl cation and cyclopropenyl anion? These are delocalized. Why? You can shift this double bond this side, the plus sign should be shifted here. Again, if you shift this double bond this side, the positive charge will be shifted here. So, delocalization in the ring is possible here. So, it satisfies the second rule. What about this? In the same manner, the negative charge can be shifted with this pi bond. So, it is also delocalized system. Here, you can say easily 2 single bonds are continuously present here. So, it disobeys the second rule, that is pi electrons are not completely delocalized. Here, though it contains 2 single bonds in the adjacent position, it has a positive charge which can be shifted like in cyclopropenyl cation. So, this is delocalized system. Here, negative charge is involved in the delocalization. So, it is also a delocalized system. So, now we ruled out this molecule because it disobeys the second rule. Am I right? So, it is not an aromatic. Which one? Cyclopropene is not an aromatic. Right. Next one. Coming to the third rule. The molecule should possess 4n plus 2 pi electrons. Total number of pi electrons should be in the form of 4n plus 2. How many pi electrons? 6 pi electrons. We already studied that if 2, 6, 10 or 14 pi electrons are present in the molecule, it obeys Huckel's rule. So, it obeys the third rule. So, this molecule is aromatic because it satisfies all the three rules. Coming to this 10 pi electrons, so it also obeys Huckel's rule. So, it is also aromatic. What about this compound? 14 pi electrons are there. If a molecule possesses 14 pi electrons, it also obeys Huckel's rule, and anthracene is aromatic. We already ruled out this molecule as non-planar. Because it is non-planar, it is non-aromatic or not aromatic compound, and we ruled out this also. Now come to this compound. Coming to this cyclopropenyl cation, 2 pi electrons are here with delocalization. So, it is aromatic. What about this cyclopropenyl anion? Here you can find electrons here also which are involved in delocalization. So, you can say 2 plus 2, 4 pi electrons present in this system, which is not in the form of 4n plus 2. It contains only 4n pi electrons, which is called anti-aromatic system. So, it is not aromatic compound, it is anti-aromatic. What about cyclopentadiene? It contains, already we ruled out this because the second rule is not obeyed by this compound. So, it is not aromatic compound. This cation contains 4 pi electrons. I told you already, if 4 pi electrons are there, it is anti-aromatic system. It is not satisfying this rule. So, coming to this cyclopentadienyl anion, how many electrons? 2, 2. These 2 electrons are also involved in the aromatization. So, totally this contains 6 pi electrons which obeys Huckel's rule, hence this molecule is aromatic. So, what is the need of studying this aromaticity? I told you already, if the compound is said to be aromatic, if the compound obeys all these 3 rules, then it is the more stable system. So, this aromaticity is the reason for the stability of the ring compounds. I hope you understand all these things.